Hello College Algebra and welcome to 6.4. This is multiplication inverses and all the different things with matrices and equations. So again, continuing with matrices, I hope you enjoy it. I kind of think they're fun. Something a little different. Alright, so we're going to find the multiplicative inverse of a matrix. Maybe, there we go. And matrix equations. So first we have to figure out how to find that multiplicative inverse. We have to solve them, and I think we're actually going to skip the encoding and decoding messages because that won't be on anything we actually need. So right here we have, I'm going to let A equal matrix and I equal the identity matrix. Now when you multiply a matrix times its identity in either order, you should get the matrix back. So let me show you how this works. The identity matrix for a 2 by 2 is 1, 0, 0, 1. The diagonal is always 1, is what you're looking at. So now we want to multiply these, and I'm hoping you remember. So again, this is row 1, column 1. So I have to multiply row 1 times column 1. Now remember, we do this position to position. So 7 times 1 plus 4 times 0 gives us 7. Now we have to do row 1, column 2. So same thing, row 1, but now this column. 7 times 0 is 0, and then 4 times 1 is 4, giving us 4. Now we do this again. Now we're moving down to the second. Remember, this is row 2, column 1. So we're taking row 2 times column 1, position to position. So 8 times 1 is 8, plus your second one is 5 times 0, which is 0. So your answer is 8. And then again, we have to do row 2 times column 2. So we're taking 8 times 0, which is 0, plus 5 times 1, which is 5. We got the exact same matrix, identity matrix. It works the same way in reverse. It doesn't matter which order you multiply them in. So an identity for a 2 by 2 is the diagonals 1. I want you to pause and see if you can get the 3 by 3 and the 4 by 4. So it goes 1, 0, 0, 0, 1, 0, 0, 0, 1. Diagonals 1, everything else 0. Same thing is true by a 4 by 4 or 5 by 5. It doesn't matter. 4 by 4s, we've got to have 4 of these. Alternate where the 1 goes. And there is, your identity for a 4 by 4. Nothing too earth-shattering yet, right? Okay, now we want to find inverses for matrices. And, excuse me, when you do this, this is the actual equation, right? So the first thing they find is what we call the determinant. And the determinant is when you take the first column and you multiply them, so AD, and you subtract the diagonal going the other way. So minus C times B. That gives you the determinant. Now, I always take and I flip the first diagonal. So I take these ones here and I change their position. So the D and the A switch. You negate the second diagonal. What that means is you take everybody's sign and you change it. So you don't make it negative, you change the sign. And then your last step is you divide everybody by the determinant you found in step 1. All right, let's show you how this works. This is what I want to find the inverse of. So my step 1 is I got to find the determinant. So I take 2 times 4, which is 8, 3 times 5, which is 15. So my determinant is 8 minus 15, which is negative 7 right here. Now, step 1, so you draw out your diagonal. I know it's written here. You take the 2 and the 4 and you flip their spots. So the 4 becomes first and the 2 becomes second. Then you take the 3 and the 5 and you change their signs. Now since 3 is positive, he is now negative. 5 was also positive, so he is now negative. Your last step is to divide everybody by the answer you got here. So we're dividing everybody by negative 7. And that is what we call an inverse matrix. Okay, pause and do yours. Step 1, you should have multiplied down, 2, multiplied up, 15. You always take the first diagonal minus the second. So 2 minus 15 equals negative 13. That is your determinant. We will use him later. So now we draw in our matrix. We flip these two. So the 1 goes here, the 2 goes here. Change these guys' signs. So this is a negative 3 and a negative 5. Last step, divide by the determinant you got in step 1, which is negative 13. If you wanted to simplify these two negatives, make a positive, that would be an awesome idea. And you are finished. Inverses are pretty good, huh? Now, to find an inverse of our larger matrix is not so easy. And we're going to do a thing called an augmented matrix. Now, to do this, you write, I'm going to give you a matrix here, and it is a 3 by 3. So then I draw a line. I can only do it with square matrices. And I put the identity on the second side. So this is the identity matrix. The goal is to flip the two. So remember before how we solved these things? And we got the 1s in the diagonal and the 0s, everything else? We do the same thing, except everything we do, we have to do it to the other side of the matrix also. So we start here, and we already have a 1. So we're happy. So the next step is I have to get this one right here to a 0. So to get him to a 0, remember you're looking at this column, I would take the top one by negative 1 and add it to the bottom row. So we're going, I should move this up so we can see a little better here. So we're going to take the top row by a negative 1 and add him down. So I'm going to multiply by a negative 1 and add down. So remember we put our little numbers here. Negative 1, 1, 0, negative 1, 0, 0. So you have to do it all the way across. Now I'm going to add down. Row 1 stays the same. Row 3 stays the same. Row 2 is the only one changing. So negative 1 plus 1 is 0. 1 plus 0 is 1. 0 and negative 1 is negative 1. Negative 1 and 0 is negative 1. 0, 1, 1, 0, 0, 0. Okay, so we got our 0 here and our 1 here. Life is good. So now we're going down here and we need to get this guy to a 0. So that means I have to multiply the top one by a negative 6 and add down. So to do that, first row stayed the same, nothing changes. Second row stayed the same, nothing changes. So let's do this multiplication. So this is negative 6, 6, 0, negative 6, 0, 0. Now we're adding the red ones down. Negative 6 plus 6 is 0. 6 plus negative 2 is 4. 0 and negative 3 is negative 3. Negative 6 and 0 is negative 6. 0 and 0 is 0. 0 and 1 is 1. So we've got the 1, 0, 0. Now I have to get the 4 to a 0. So to do that, we're going to multiply the second row by negative 4 and add down. So if we multiply by negative 4, we have a negative 4, positive 4, positive 4, negative 4. These guys stay zeros. And add down. So row 1 stays. Row 2 stays. Row 3. 0 plus 0 is 0. Negative 4 plus 4 is 0. 4 and negative 3 is 1. That was nice. 4 and negative 6 is negative 2. Negative 4 and 0 is negative 4. 0 and 1 is 1. So we've got the first half done. Now remember we also have to work backwards. So now this negative 1 here has to become 0. And I can do that by taking the bottom row and adding it to the middle. So the first row stays, second row stays. Nothing changes. Okay, now since we're just adding up, we don't have to change anything. So it goes 0 plus 0 is 0. 0 plus 1 is 1. 1 plus negative 1 is 0. Negative 2, negative 1, negative 3. Negative 4, 1, negative 3. 1, 0, 1. So this guy back here is very important. We got to check those numbers multiple times. So now we're doing a little better. We got 2 zeros here already. So the only one we have left is this negative 1. So to get him, I'm going to take row 2 and add it to row 1. No multiplication again. So last row stays, middle row stays. First row is the one we're changing. So 0 and 1 is 1. 1 and negative 1 is 0. 0 and 0 is 0. Negative 3 and 1, negative 2. Negative 3 and 0, negative 3. 1 and 0, 1. This means this matrix back here that we changed from the identity is called the inverse matrix of A. If we multiply the A times its inverse, we will get the identity, which is the 1 diagonals. Okay, I hope you did a good job on that. It's quite a lot. Okay, it is your turn. So pause and do this and make sure you get it right. Or watch your signs, I should say. So 1, 0, 0 is what you should add in here. Okay. I'm going to pause and let you do your work, so make sure you get this done right. All right, I hope you did a good job. I'll show you how I did it, but yours could be completely different. The ending one is the only thing that has to be the same. I tried something a little different here. First, I multiplied the first row by negative 1 just to change him to a 1. And then we always seem to work down. So I wanted to work up to show you that you could do this. So I took the last row times 2 and added up. So when I added up, I got a 0, 1, 0 in the middle. See how nice that worked? Which was helpful. Then a 0, a 1, and a 2. Then next, I had to get rid of this guy. I needed him down to a 0. So I took the first one and I added to the last. So the first 2 stayed the same. Then we added these down. 1 and negative 1 is 0. Negative 1 and 1 is 0. 3 and negative 2 is 1. Negative 1 and 0 is negative 1. 0, 0, 0. 0, 1, 1. All right, so we're doing really good so far. Now I need to get rid of that negative 1 or the 3. I chose the negative 1. So all I did here was I added the second row to the first row. So bottom row stayed, middle row stayed. First row became 0 and 1, which is 1. 1 and negative 1 is 0. 0 and 3 is 3. 0 and negative 1 is negative 1. 1 and 0 is 1. 2 and 0 is 2. Now I needed to get rid of the 3. So I multiplied the negative 3 by the top row. That meant the bottom row stayed, and the middle row stayed, and only the top row changes. So 0 and 1 was 1, 0 and 0 is 0, negative 3 and 3 is 0, 3 and negative 1 is 2, 0 and 1 is 1, negative 3 and 2 is negative 1. So this is my inverse matrix. Now, if you actually want to check that, you do the math. So you would take the original matrix, which was, so this is your check, negative 1, 1, and 3, negative 3, I'm sorry, 2, negative 1, and 4, negative 1, 1, and negative 2. You would multiply this by your inverse, which is the one you just found, 2, 1, negative 1, 0, 1, 2, negative 1, 0, 1. And your answer should be the 1, 0, 0 identity matrix. So let's check. So we're going to take row 1 times column 1. So this would be negative 2 times 2, negative 1 times 2, which is negative 2, plus 1 times 0, which is 0, plus negative 3 times negative 1, which is plus 3. Look at there. That equals 1. Now, you do it again. So now I have to do the second column. Same thing. So negative 1 times 1 is negative 1. 1 times 1 is 1, so I got 0 right now. Negative 3 times 0 is 0. So the total is 0. And then you do it again. You would take this here times your third column. So negative 1 times negative 1 is 1. Then we would take 1 times 2, which is 2. And then we would take negative 3 times 1, which is negative 3. Add those all up and we get 0. Look at there. And then you continue that on. You would now do your second row and then your third row, and you're going to get 0, 1, 0, 0, 0, 1, which shows you that it works. I just don't want to do all of that right now, but you are more than welcome to. It's a great check. Okay, let's continue on here. We're going to use inverse matrices to solve an equation. So right here, I have, here's my matrix A. X is what I'm trying to find, and B are the solutions. To find X, you have to take the inverse of A times B. So to move this guy over, the math is the inverse of A times the B. Is how I would find my values of X, or X, Y, and Z. All right, so let's show you how this works. This is my equation that we set up with, my three equations. So I have 1, 0, 2, negative 1, 2, 3, right here. 1, negative 1, 0, here. X, Y, and Z are what we're trying to find. All right, so those are my variables. And these here are just the solutions. Now, the first step is to find the inverse of this matrix. So that's the 1, 0, 0, 1 thing. So now 1 is good. Negative 1 needs to become 0, so we add down. So first row stays, second row stays. Third row becomes 0. Oh, I cheated and added up so it would work better. Sorry about that, kids. All right, so here I took and added this way, so I get a 1 right here. So I got first row stays, bottom row stays, just like before. But now 1 and negative 1 is 0. Negative 1 and 2 is 1. 0 and 3 is 3. 0 and 0 is 0. 0 and 1 is 1. 1 and 0 is 1. So we've done well. Next, we want to take and go through here. I've got this guy gone. He's a 1, so this one needs to disappear. So in order to make him go away, we have to multiply by a negative 1 and add down. So this is negative 1, 0, negative 2, negative 1, 0, and 0. That means row 1 stays, row 2 stays. Only row 3 changes. I think I should quit, for crying out loud. What am I doing to you? All right, let's do this again. I want this here to be 0. Oh. I don't know if I showed my work. Okay, we're going to start over here, and I can't rewind, so you're in trouble. Here we're going to take this here times a negative 1 and add down. So negative 1, 0, negative 2, negative 1, 0, 0. So in other words, row 1 stays, row 2 stays. They do not change. Negative 1 and 1 is 0. 0 and negative 1 is negative 1. Negative 2 and 0 is negative 2. Negative 1 and 0 is negative 1. 0 and 0 is 0. 0 and 1 is 1. Okay, sorry about that. Now to get this guy to a 0, I just take these two and add them together. Okay, row 1 stays, row 2 stays. Row 3 changes. 0 plus 0 is 0. 1 and negative 1 is 0. 3 and negative 2 is 1. 0, negative 1, negative 1. 1 and 0 is 1. 1 plus 1 is 2. So we're doing awesome. Now I need to get this 3 to a 0. So in order to get him to a 0, I'm going to take the bottom row times negative 3 and add up. So 0, 0, negative 3, 3, negative 3, negative 6. So row 1 stays. Row 3 stays. Row 2 changes. 0 plus 0 is 0. 0 and 1 is 1. Negative 3 and 3 is 0. 3 and 0 is 3. Negative 3 and 1 is negative 2. Negative 6 and 1 is negative 5. Okay, we're doing really well. All I got left to get rid of is the 2. So to get rid of the 2, I'm going to multiply the bottom row by negative 2 and add to the top. That means the bottom row stays, the middle row stays. The only thing that changes is row 1. So we've got 0, 0, negative 2, 2, negative 2, negative 4 is what we're adding to the top. So 0 and 1 is 0, 0 and 0 is 0, negative 2 and 2 is 0. We've done well on this side. 2 and 1 is 3, negative 2 and 0 is negative 2, negative 4 and 0 is negative 4. So this is my inverse matrix. So now we're going to take that inverse matrix. So this is the inverse matrix we just found. So this is the inverse times my solutions are my answers, which is the B. And that's going to give me my x, y, and z equal. So we are taking a 3 by 3 times a 3 by 1, which means I'm going to get a 3 by 1 when I'm done. So I'm going to have 3 rows, 1 column. So we do this just like before. We take the first row times the first column. So you're taking 3 times 6 plus -2 times -5 plus -4 times 6 right here, and you've got 4. Next one, now you're going to go to your second row. You're going to take 3 times 6, which is your 18, plus -2 times -5, which is 10, plus -5 times 6, which is -30, which is going to give you -2. Now you go down to your last row, same thing. So you can -1 times 6, which is -6, plus 1 times -5, which is -5, plus 2 times 6, which is 12, which gives you 1. So this means x equals 4, y equals -2, z equals 1. Or there's your 3D point. Okay, we do not have the calculator mode, so we cannot do this section, unfortunately. And this would not be a bad practice. So let's do this here practice, and then we're done, because we are not going to do the rest of the where we decode and encode things. So pause and give it a shot. Okay, remember there's multiple ways to do this. I'm just showing the way I did it. I took the first one by -2 and added down, which gives me this matrix. Then I got rid of the 3, so I multiplied row 1 by -3 and added down again, which gives me the second matrix. I was already at a 1, so I had to get rid of the 4. So I multiplied second row by -4 and added down. Next, I needed to get rid of this -4, so I multiplied by 4 and added up. Okay, now I had to move to the top of the page because I ran out of room. Sorry about that. So now we're at this matrix, so I had to get rid of the 5, so I multiplied by 5 and added up, giving me this final matrix here. So this is the inverse matrix that I had to multiply by the solutions, which were 0, 1, 3. And the answer, now when you multiply, you take this row times this column, correct? So -24 times 0 is 0. So all the first ones are going to go away. So we took the 20 times the 1, which is 20. The -5 times the 3 is -15, and I got 5 for my first answer. So x is 5. Then 18 is 0. -15 times 1 is -15. 4 times 3 is 12, giving me -3 for y. 0, -4 times 1 is -4, plus 3, giving me -1 for z, and we're done. Okay, we are not doing decoding, so you do not have to worry about that, and you can also take that off of your homework. So right now you're on to your homework. I hope you do a good job. Make sure you post questions if you have any. Thank you and have a great night.